When we think about stars, we often imagine small, sparkling points in the evening sky. This is how we perceive them from Earth. However, stars like Betelgeuse are entirely different. In fact, Betelgeuse is so immense that it is far larger than our Sun. For a long time, this star has puzzled scientists. Recently, though, something even more unsettling has been happening with Betelgeuse, causing concern among researchers and experts alike. In this video, we delve into the startling updates regarding Betelgeuse, including its predicted demise as forecasted by the James Webb Space Telescope. We'll also explore how these developments might impact our galaxy and life on Earth, as explained by physicist Michio Kaku. Betelgeuse is a captivating wonder, a massive star that has intrigued astronomers for many years. The first discovery of this star came from the Greek astronomer Ptolemy. This star is so enormous that it can be spotted in the evening sky from Earth, particularly during the winter months. If you have a passion for astronomy, you've probably seen or heard about it. Betelgeuse is the bright, reddish-orange star that marks the upper left shoulder of the Orion constellation. It's an ancient star, one of the most luminous in the night sky. However, its brilliance is not constant and it fluctuates. This variability is one of the fascinating traits of Betelgeuse, but it's not the only unique feature. Let's dive into some of Betelgeuse's particular qualities. Most of the stars we see at night are incredibly distant from our planet. The closest one, Proxima Centauri, is located 4.2 light-years away. If you're unsure how the term light-year connects to distance, imagine traveling at the speed of light for an entire year. It's been established that light travels at 186,000 miles per second, and the total distance light covers in a year amounts to 1 light-year, which equals billions of miles. So, when we say Proxima Centauri is 4.2 light-years away, it means that it is billions of miles from Earth. But some stars, like Betelgeuse, are even further. Betelgeuse is approximately 600 light-years away from Earth. This means if we could travel at the speed of light, it would take us 600 years to reach it. Unfortunately, we can't travel at that speed, not even with our fastest spacecraft. Still, Betelgeuse shines brightly in our sky, despite its great distance. If you're wondering how Betelgeuse can be so radiant from so far away, the answer lies in its exceptional characteristics, such as its enormous size and inherent luminosity. Betelgeuse is about 500 times larger than the Sun, and its radius is believed to be several times that of the Sun. When observed with advanced telescopes, it appears as a disk rather than a small point of light, unlike most other stars. This phenomenon is thought to be caused by the reactions taking place in its outer layers. Regarding its mass, Betelgeuse weighs between 12 and 19 times the mass of the Sun. One solar mass is equivalent to 2 times 10 to the power of 30 kilograms, but astronomers can't pinpoint the precise mass of Betelgeuse because there are no other planets or bodies orbiting it for comparison, and measuring it directly is impossible from Earth. What makes Betelgeuse so remarkable is that it is many times more massive than our Sun. The star's brightness ranges from a magnitude of +0 to +1.6. In simpler terms, Betelgeuse is 16,000 times more luminous than our Sun, earning it the nickname of a red giant. However, its brightness is not constant, it fluctuates. This variation is caused by the star's pulsations. When Betelgeuse expands, it becomes brighter, and when it contracts, it dims. These cycles can last anywhere from 10 to 100 days or even longer. An interesting aspect of Betelgeuse is that its surface contains dark magnetic spots, areas where the magnetic field is far stronger than the normal surface. These spots inhibit the flow of hot gases to the surface, cooling those regions. Betelgeuse has far more of these spots compared to our Sun, which explains why it is cooler than the Sun, despite its greater size and brightness. While our Sun also has dark magnetic spots, Betelgeuse's spots are much larger and more numerous. To give you a sense of scale, some of these spots can be twice as large as Earth. Betelgeuse also has a magnetic field that's 1,000 times stronger than the Sun's. This magnetic field is responsible for the spiral or arc-like patterns that appear on its surface when observed through a telescope. The surface temperature of Betelgeuse is around 3,500 Kelvin, which contributes to its low energy output and faint red color. It wasn't always a red star, though. Around 100,000 years ago, Betelgeuse had a yellowish hue, similar to our sun. Over time, its color shifted to orange, then red, and about 10,000 years ago, it began transforming into the red star we see today. This transformation led scientists to conclude that Betelgeuse is aging. Betelgeuse emits up to 10,000 times more energy than our sun. Had it been closer to Earth, it would have outshone our sun. If it were even slightly nearer, we might be able to see it during the day. However, because of its enormous size, if Betelgeuse replaced the sun, it would engulf Earth and the nearby planets. Even if Betelgeuse could somehow match the sun's energy output, it would still radiate far more energy, making it even more powerful than our sun. Despite being 600 light-years away, Betelgeuse is still visible to the naked eye, which is remarkable. Our sun is only 8.3 light-minutes away from Earth, which is why it's so much brighter. Betelgeuse, located in the Orion constellation 600 light-years from Earth, is one of the most massive stars we know. Its vast size, around 500 times that of our sun, is its most striking feature. If placed in the center of our solar system, Betelgeuse would easily encompass the orbit of Jupiter. This immense size causes Betelgeuse to appear as a disk when viewed with powerful telescopes, unlike most stars which appear as tiny points of light. Although it's not the most massive star in the universe, Betelgeuse's mass ranges from 12 to 19 times that of the sun, depending on various estimates. One of the most fascinating aspects of Betelgeuse is its variability in brightness. Unlike the sun, which remains relatively stable, Betelgeuse experiences irregular fluctuations in brightness. These fluctuations are believed to be the result of pulsations within the star. At its brightest, Betelgeuse is 16,000 times more luminous than the sun, but during its dimming episodes, its brightness can drop significantly. These variations have intrigued astronomers for centuries and provide valuable insights into the star's life cycle and characteristics. Betelgeuse's surface temperature is comparatively low for a star of its size, around 3,500 Kelvin, which gives it its reddish-orange color. As a red giant star nearing the end of its life cycle, Betelgeuse has exhausted the hydrogen fuel in its core and is now fusing heavier elements. This fusion process generates energy and causes the star to expand. The star's surface is also marked by dark magnetic spots, much larger than those found on the sun, which restrict the flow of hot gas from the interior to the surface, leading to cooler regions. Betelgeuse has been studied for centuries by astronomers from various cultures, including the Greeks, Egyptians, and Chinese, who recorded its position and brightness. In Arabic cosmology, Betelgeuse is called Yad al-Jaza, meaning the hand of Orion, due to its prominent position in the constellation. Recently, Betelgeuse has drawn increased attention from scientists due to a series of dimming episodes that began in late 2019 and continued through mid-2021. During these episodes, the star's brightness dropped to unprecedented levels, sparking speculation that Betelgeuse might soon go supernova. Supernovae are explosive events that occur when massive stars run out of fuel and collapse under gravity, triggering a massive explosion that can outshine an entire galaxy. If Betelgeuse were to go supernova, it would be one of the brightest objects in the sky, visible even during the day. The possibility of Betelgeuse undergoing a supernova has captured the imagination of both scientists and the public. Astronomers continue to monitor the star using telescopes and space-based observatories to learn more about its behavior and evolution. Betelgeuse's status as a red supergiant star provides valuable insight into the later stages of stellar evolution. These stages involve the fusion of heavier elements in the star's core and the dispersal of these elements into the interstellar medium. Studying Betelgeuse helps astronomers understand the complex processes that shape the universe. When we gaze at the night sky, we often see stars as tiny, distant points of light. But stars like Betelgeuse, located in the Orion constellation, are much more than that. They are among the largest and most famous stars visible from Earth, and their stories are full of cosmic drama. Betelgeuse, approximately 600 light-years from Earth, is a red supergiant star in the final stages of its life cycle. Its diameter is estimated to be 500 times larger than that of the Sun. If placed at the center of our solar system, Betelgeuse would extend beyond Jupiter's orbit, dwarfing our Sun. Despite its immense size, Betelgeuse's brightness fluctuates significantly. It is 16,000 times more luminous than the Sun at its peak, but it dims considerably at times. This dimming, first observed in late 2019, sparked public curiosity about whether the star might be on the verge of becoming a supernova. Astronomers have been intrigued by Betelgeuse's behavior for a long time. The dimming in 2019 and 2020 was unprecedented, making Betelgeuse one of the dimmest stars in the Orion constellation. Some speculated that this dimming was a sign that the star was preparing to explode in a supernova. However, recent studies suggest that the dimming was likely caused by a dust cloud forming around the star. Betelgeuse frequently expels material, and at times, these materials clump together to form dust clouds, obscuring the view of the star and reducing its apparent brightness. Though this dust cloud temporarily reduced Betelgeuse's brightness, the star itself remains active, and there's no direct evidence to suggest that it's on the verge of exploding. To fully appreciate Betelgeuse's significance, we must examine its life cycle. Like all stars, it began in a molecular cloud of gas and dust. For most of its life, Betelgeuse has fused hydrogen into helium, similar to the Sunday. However, Betelgeuse is much more massive than the Sun, so it has exhausted its hydrogen fuel and is now fusing heavier elements like carbon and oxygen. This fusion process generates even more energy, causing the star to expand and evolve into a red supergiant. Stars like Betelgeuse end their lives in dramatic supernovae. When it can no longer sustain fusion in its core, gravity will cause Betelgeuse to collapse, triggering a massive explosion. This explosion will outshine the entire galaxy for a short period. If Betelgeuse were to go supernova, it would be visible during the day from Earth, even though it is 600 light-years away. This event would scatter elements like iron, calcium, and oxygen into space, enriching the interstellar medium and helping to form new stars and planets. Supernovae play a crucial role in creating the elements that make up planets, including Earth. After a supernova, the star's outer layers are expelled into space, while its core may collapse into a neutron star or, if massive enough, a black hole. Though Betelgeuse's eventual supernova will be a spectacular event, there's no need for concern. This explosion is expected to happen within the next 100,000 years, so it won't affect us anytime soon. Even if it were to explode tomorrow, the distance between Earth and Betelgeuse is so great that it wouldn't pose any danger to our planet. The fate of Betelgeuse, though fascinating, won't have any immediate impact on Earth. Even if the star were to go supernova, the distance of 600 light-years means that its explosive energy wouldn't reach us in a way that would harm our planet. However, this does highlight just how powerful and dynamic stars like Betelgeuse can be, and how their life cycles contribute to the ongoing evolution of our universe. The explosion of Betelgeuse into a supernova will likely be an awe-inspiring event for astronomers and anyone lucky enough to observe it, though it's still far in the future. This event would not only be a stunning spectacle in the night sky but also serve as a key moment in understanding stellar life cycles, as the death of massive stars like Betelgeuse plays a vital role in the distribution of heavy elements throughout the galaxy. These elements are critical to the formation of planets and even life, further underscoring the interconnectedness of cosmic processes. Astronomers continue to monitor Betelgeuse closely. They are using advanced telescopes and space observatories to track its brightness, pulsations, and any changes in its behavior, keeping an eye out for any signs of a supernova. Despite the recent dimming episodes, Betelgeuse is far from an immediate threat, and scientists are still studying the mechanisms behind its fluctuations. Understanding why this star, and others like it, behave the way they do offers invaluable insights into the fundamental forces at play in the universe. The study of stars like Betelgeuse is also a key part of advancing our knowledge of the universe as a whole. It teaches us about the life cycles of stars, the dynamics of galaxies, and the processes that lead to the formation of planets and other celestial bodies. Furthermore, observing these distant stars also provides clues about the early universe and the origins of the elements that make up everything we see around us. In the grand scheme of things, while Betelgeuse's supernova event might not happen for another 100,000 years, its eventual explosion will leave a lasting mark on our understanding of the cosmos. For now, we can continue to marvel at its variability, its massive size, and its key role in the greater story of the universe. Stars like Betelgeuse remind us that the universe is far from static. There's always movement, change, and mystery unfolding across vast distances. In the end, the study of such incredible stars not only fascinates us with their power and beauty, but it also connects us to a deeper understanding of the forces that shape the universe and everything within it.